All right, guys, so I'm going to go over factoring. The first step that we do when we factor is always to take out the greatest common factor. So if I'm looking at example 1, I'm going to look for what number goes into all three of these numbers. So the number that goes into 14, 24, and 8 is 2. So if I divide 2 into 14, I get 7k squared. If I divide 24 by 2, I get negative 12k. And last, I have negative 8 divided by 2 is negative 4. So the next thing I notice is that this is a trinomial. There are 3 terms, 1, 2, 3. So I'm not going to factor this using difference of squares or difference of cubes or anything like that. I know that I'm going to need to break this down to be what multiplies to 7k squared. So 7k times k is what multiplies to 7k squared. And then what multiplies to 4. So I'm going to try 2 and 2. And then with a trinomial, like we did when we were multiplying, this term, 2 times k is 2k, and 7 times 2 is 14k, need to add to the middle term. So my middle term here is a negative 12k. So if I have 2 and 14, if 14 is negative, then they will add to a negative 12. So 7 times 2 needs to be the negative, and 2 times k needs to be the positive. So the last thing I'm going to do here is make sure that I bring down my coefficient that we took out at the beginning. So that's a 2 here. And then I'm going to check my signs. So does 7k times k give me a positive 7k squared? Yes. Does positive 2 and negative 2 give me a negative 4? Yes. And then we already checked to make sure that the middle term added to give me negative 12k. So our answer here is 2 times 7k plus 2 times k minus 2. All right, guys, so we're going to move on to number 2. And again, the first step always when factoring is to pull out what's in common. If I look at 10, 33, and 54, there's not really any numbers that stand out to me that go into all of them. 10 has factors of 1, 10, 2, and 5, and I believe none of those go into 33. So I really don't have to worry about that here. I do notice that all of them have an a of some sort. So we have a to the 4th, a to the 3rd, and a to the 2nd. So I know that all of them have at least a to the 2nd. So that's actually what I'm going to take out. A to the 2nd. So 10a to the 4th divided by a squared would give me 10a squared. We're taking 2 of the a's away, so that gives us 2 out of the 4. Then I have 33a cubed, and I'm dividing by a squared, so that's going to give me 33a. And then I have 54a squared divided by a squared, so the a squareds will just cancel off. So again, I look at this, is this a binomial, a trinomial? I notice that it is a trinomial. So then we are going to go to factoring like this, where the first thing we do is we just break down what multiplies to 10a squared. So I'm going to try 5a times 2a. And then for 54, what multiplies to 54? Let's see, 9 times 6? So I have here 2 and 6 together. So there's actually a rule when you factor trinomials, you can't put something together that has the same common factor. So does 2 go into 6? Yes. So we can't actually do that. So I'm going to have to switch these. I'm going to switch the 6 to be over here and the 9 to be over here. Now these have nothing in common and these two have nothing in common. So let's check if these add to the middle term. We have 12a and 5 times 9 is 45a. So my middle term is a positive 33. And I can get positive 33 from here. So if I have 45a and I subtract 12, then that will give me my 33a that I'm looking for. So that means the parentheses here need to be the negative, so that I would get the negative 12 when I multiplied these two. And the parentheses here need to be a positive, so that I would get 45 and be able to get my 33. So again, make sure you bring down what you take out at the beginning, because that's still part of the question. And the last thing is always check your signs. So I have a negative 6 times a positive 9. Is that negative 54? Yes. And is 5a and 2a positive 10a squared? Yes. So my final answer here is a squared times 5a minus 6 times 2a plus 9. All right, for question 3, and for all factoring, first step we always do is to look for that greatest common factor. So if I'm looking at 4a squared minus 36a plus 32, I notice that 2 goes into all of these. So I'm going to take out a 2. And I get 2a squared. 36 divided by 2 is 18. And 32 divided by 2 is, I don't know, a good number. 16. So I'm looking at this, and I actually see that 2, 18, and 16 have another common factor. So that means I can take out another 2. I already had a 2 taken out, but now I'm going to take out that other 2. And that's going to give me 2a squared divided by 2 is a squared. 18 divided by 2 is 9. And 16 divided by 2 is 8. So in front right here I have 2 times 2, which is actually 4. So that means I could have taken out a 4 from the very beginning, but I didn't see that, so I just took out what I did see and then realized there was something else afterwards. So again, I'm looking and I see that this is a trinomial. So a trinomial we're going to factor using this guess and check method. A squared, what multiplies to a squared is a and a. What multiplies to 8 is 2 and 4. And when I check this, I get 2a and 4a. And are those ever going to add to 9? I need a negative 9a. So 2 and 4, if I add them, I get 6. If I subtract them, I'm going to get a negative 2 or a positive 2. So that's not going to work. So instead of using 2 and 4, I'm going to use different factors for 8. So I'm going to just write the question here. 4a squared minus 9a plus 8. Again, break down what multiplies to a squared, which is a and a. And then we already tried 2 and 4 over here, so now I'm going to try 1 and 8. So 1a and 8a. And remember, I'm trying to get a negative 9a. So the only way that a 1a and an 8a are going to give me a negative 9a is if they're both negative. Bring down that 4 that we factored out at the beginning. And then make sure you check your signs. So I have a negative 1 and a negative 8 multiply to a positive 8. That's good. And a times a does give me positive a squared. So my final answer here is 4a minus 1 times a minus 8.